Hi everyone, my name is Jeanette Cabrera, and I will be sharing with you today on how the gut microbiome can be transformed to help with lactose intolerance. So to start off with, how many of us like to enjoy an ice cream on a warm summer day or a delicious meal of cheesy pasta? I know I sure used to. That is until recently when I became dairy-free to avoid the severe gastrointestinal symptoms associated with lactose intolerance. Lactose intolerance is associated with the development of gas, bloating, nausea, abdominal cramps, and pain associated with diarrhea after ingesting lactose-containing foods. Lactose is typically broken down in the small intestine by an enzyme called lactase, and individuals with lactose intolerance often do not produce sufficient lactase. Therefore, lactose is not fully digested. It passes into the colon where bacteria ferment it, and this causes symptoms. The most common cause of lactose intolerance is a loss of lactase, which is encoded on chromosome 2. And I know for me personally, this did happen later in my adult life. And now we're working through a new dietary lifestyle. So, dairy removal and turning to plant-based dairy substitutes has become a common treatment option for individuals who are lactose intolerant. This raises concern about calcium and vitamin D deficiencies, as discussed in a review examining lactose intolerance, dairy avoidance, and treatment options. In addition, bacteria with beta-galactosidase can help digest lactose and reduce symptoms of lactose intolerance when consumed as probiotics in fermented dairy products, such as yogurt. This leads to my question. Does understanding the gut microbiome hold the answer to disease treatments? Modulating the gut microbiome with specific probiotics is a therapeutic approach to managing gastrointestinal symptoms, as evidenced by one study that showed symptom relief when participants took Lactobacillus acidophilus DDS1. This study is critical because it provides clinical evidence that a specific probiotic strain can effectively relieve symptoms of lactose intolerance without directly increasing lactose digestion. This is a safe and accessible intervention since DDS1 is widely available, affordable, and offers a practical solution. One study found that among lactose intolerant individuals, higher abundances of bifidobacterium were detected compared to lactose tolerant individuals, even though both groups consumed similar amounts of dairy. Bifidobacteria have been shown to increase symptom load by metabolizing lactose into gases and acids, which triggers bloating and pain. So therefore, you can also target the bacteria that are having an effect on gastrointestinal symptoms by lactose and target those bacteria by either, lowering them or having some sort of commensal bacteria to help alleviate the symptoms that is caused by the bifidobacteria. So that is another approach that is in a way, changing the microbiome to help these symptoms. Challenges in studying the gut microbiome modulation include lack of longitudinal studies and the diversity of gut microbiomes among individuals. With 65% of the world's population being lactose intolerant, this is a matter of widespread dietary and digestive health. The gut microbiome can be modified through dietary changes and probiotics, which can reduce symptoms even in genetically predisposed individuals. Non-invasive and low-cost interventions are available for lactose intolerance. If people who have steered away from lactose products can reintroduce it into their diet, this can help restore nutrient consumption and benefit those globally. This leaves us thinking about the applications for the potential for the gut microbiome has to not only alleviate lactose intolerance, but possibly other diseases. Thank you for listening to my TED Talk, and I hope for some interesting discussions to occur from this. Thank you.